In programming, there is something known as the programming paradigms. You can think of this as a classification, a style, or just a general way to write code. You may already be familiar with one of these paradigms, functional programming. In this video, you will learn about another popular one, the object-oriented programming paradigm, often referred to as OOP. OOP revolves around the idea of organizing our programs using objects to group related data and functionality. This is in contrast to the functional programming approach, where the data used in the app needs to be kept separate from functions that operate on that data. Let's explore this concept further using some code examples from the two paradigms. Suppose we are asked to write some code that calculates the total cost of buying a pair of shoes. The code needs to calculate the total price, which is the shoes multiplied by the tax amount. To code this solution, you decide that you need variables to store the values for shoes and tax and total price. You need a function, which you will call total price, to perform the calculation of multiplying the shoes by the tax. Finally, you need to be able to output the result. Using the functional programming approach, you clearly separate a program's data from functions that work on that data. With the OOP approach, you create an object and store all data related to that object, including variables, functions, and output statements. For example, you create an object named purchase1. You may recall that functions inside objects are known as methods. Now that the purchase1 object is created, you access the total price method on the purchase1 object using the dot notation. Then you invoke the total price method, which works with data inside the purchase1 object and returns the result of 120. In fact, you can access any data that the purchase1 object has. For example, using the dot notation, you can access the shoes price data and the state tax data. An advantage to using the OOP approach is that you can build as many objects as you need. For example, you can build another purchase object and name it purchase2. Once created, you can also access the total price method on the purchase2 object, just like you did on the purchase1 object previously. You may notice that the total price method was almost the same in both the purchase1 and the purchase2 objects. This means that you can improve the objects so that both methods are identical. And you can do that by using the this keyword, which you may recall. It essentially means this object. It's important to note that the code still works exactly the same as before. Okay, so you may be wondering, why did I go through the trouble of updating the code of purchase1.choosePrice to this.choosePrice? Well, the advantage here is that rather than having to think about the name of the object whose shoesPrice property I'm trying to access, I just use the alias of the current object's name, namely the this keyword. And now I can just copy the total price method from the purchase1 object and reuse it in the purchase2 object. So, using the this keyword allows me to not really care about the current object's name, which is an improvement to the previous code I had. However, programmers are always eager to avoid wasting resources when writing code, and coding a custom method on each of the objects I build is wasteful. The solution to this is to code my objects using some sort of a template. You will learn how to create this later in this lesson using something called a class. For now, let's explore object-oriented programming principles with the example of calculating the total cost of buying a pair of shoes. Before starting, let's first quickly revisit another programming style, functional programming. This should help you understand the differences between the two paradigms. I start with var shoes equals 100, and I also add var state tax equals 1.2. Next, I declare a function which returns the value of the shoes multiplied by the value of the tax. This is written as function total price with shoes and tax in parentheses. Inside of curly braces, I add return shoes * tax. Now I'm declaring the variable to pay, which invokes the total price function and passes the shoes variable value, as well as the state tax variable value. Finally, I console log the toPay variable. When I run the code, the output is 120. So that's an example of the functional paradigm. But this time, let's build something similar with the OOP paradigm. I go to a separate file where I declare the variable purchase1 and store an object literal inside of it with curly braces. I then add the property shoes and set it to 100, followed by state tax, which is set to 1.2. The last property is total price, which is set to a function to declare a calculation variable. This variable is equal to the purchase1.choose property multiplied by the purchase1.stateTax property. The second part of the function console logs the string total price, along with the value of the calculation variable. On line 10, I call the function with purchase1.totalPrice parenthesis, which I expect to return a value of 120. I run the code, and that's indeed what I get. On another file, I'll build another OOP example. This one starts with the variable purchase2, which has the same structure as purchase1. However, the shoes value is changed to 50. In the total price function, the calculation variable is updated to access the shoes and state tax properties from purchase2. When I invoke the total price method on the purchase2 object and run the code, it returns a value of 60. Between these two OOP examples, you may have noticed that aside from accessing the shoes and state tax properties in different objects, the two methods are completely the same. This means that I can improve my objects to make both methods identical while getting the same results. I can do this using the this keyword, which essentially means this object. Let's move to another file to examine how that works. In this file, I have the same purchase1 and purchase2 objects from before, with all of the same values. In the total price function of purchase1, I replace the references to purchase1 with the this keyword. I can then copy the total price method from purchase1 and paste it into the purchase2 object, since they are now identical. I run this code and it gives me a total price of 120 for purchase1 and 60 for purchase2. This is an improvement over my original code from the perspective of reducing waste. Instead of writing custom methods for every object, this approach allows for the reuse of existing code. However, although I'm reusing the existing code, I'm now repeating this same method on each new object that is built. That is wasteful, and programs need to be efficient. This is where making templates for objects comes in. In JavaScript, one of the most elegant ways to efficiently build new objects is by using classes. Congratulations! In this video, you learned about object-oriented programming and how it differs from functional programming. With the object-oriented approach, you can code more efficiently by reusing existing code.